Okay, so this is the entry point into object-oriented programming. And we're starting off with a simple example. As you mentioned before, object-oriented programming, it's a type of programming that's oriented around objects where we're trying to replicate real-world things or objects. So I'm starting off with a person class, and this person class is going to act as a template. And this template will essentially allow me to create multiple instances of people objects. I'll have P1, I'll have P2, I'll have P3, and they will all originate from a template, which is this person class. And of course, we could have objects like, an employee. We could have an object like, cars and so forth. So I'm really starting off from a person. Now, as far as objects are concerned, they have these three things. So they usually have attributes, they have constructors, and they have methods. So this is like the main structure as far as creating a class for an object is concerned. You'll have attributes, constructors, and you'll have methods. Now, as far as attributes are concerned, these are just things that they're properties or characteristics of a class. So a person can have, and I'm saying that this is private for now. So each of these attributes will be private, and we'll talk about why it's important to be private. So I'm going to say, well, that you'll have a name. I could also say that you'll have an age. Each person will have an age, and I can cut it off here for now. So this part here is the axis modifier. This is the data type, and this is the name of the attribute. So each person will have a name and an age. Now, as far as a constructor is concerned, and this is kind of where we want to be a little more detailed about what a constructor is. A constructor will have a public access modifier, and that is because outside this file, we're going to have to access the constructor. Now, a constructor gives default values for the attributes. So you see these, the name and the age. The constructor is going to give a default value for the name, and it will give a default value for the age. So I could say, let's say I'm creating a database for, let's say, I don't know, a database for people who tend to buy alcohol. Well, their age needs to be defaulted to at least being 21. So I could set a default value of 21 for them through the constructor. So the constructor is nothing but giving default values for each object. It's instantiating it's giving values for the attributes. It starts with this. You say public, and the name of the constructor has to match the name of the class. So it has to be person. And what you'll see here is that you have options as far as constructors are concerned. You can have a default constructor, and you can also have an overloaded constructor. So the default constructor might take no parameters, and we call parameters the things we put in between the parentheses. So what I can do here is I can say I can pass in a name, and I can pass in an age. And the idea is that I will say that this name that I have on the we call this the global level, and this is the local level. So the global level will be available to every method I have or every constructor I have. But this name and age here is only available inside this in between these brackets, essentially. So I can say the name that I have on this level is equal to the name, and you can see that it's indicating where that name is coming from. The name that I have on that level is equal to the name I have there, and the name, the age that I have on the local level is the age that I have here. Now, you could just give them different names. You could say that this is a person. You could say that this is person name, and you could say that this is person age. In which case, you actually don't have to use this keyword, this is the this keyword. You could just alternatively say that this is just the person name. The name that we have up there is equal to the person name, and the age that we have up there is equal to the person age. So what we're doing is we're basically tying in each object, each person object, the name that we're passing in initially, or the age that we're passing in initially, will actually refer to the person's name in general. And so that's the idea as far as a constructor is concerned. And so we could go this route, or we could go the previous route that I mentioned before. And I guess I'll go with this one for now. That's generally the one I tend to go with. And so that's sort of a constructor. I'm going to create a main method for now just to interact with this stuff. So I'll call this, we'll call this, and I'll have a main method in here. And the idea now is that I have a person object, I have a constructor, and if I don't make these private, I can come down here and I can say person P1 equals new person, and this part here is actually, this part here, person bracket bracket, is actually referring to this part, this person bracket bracket. So I can actually come here and I get to decide what I get to pass in for a person. Initially, I can say that they'll have their name as John and then their age as 22. So you see the value in having the constructor. I get to decide initially what a person should have. And now there you can see that if I would do p1.name, if I come a little closer in here, you can see that it's giving me the option, hey, each person has an age and a name, and it even gives me their data type. So I can say p1 name is, I can change it now, essentially is what I'm doing. I can say that this is David. And now when I print out the name, I can say p1.name. You'll see that it's actually not John. It's actually not John. It's in fact the updated version, which is David. So we actually don't want people to be able to do this, and we'll talk about why, which is why we want our instance variables, or actually, and these will more commonly be called instance variables, by the way. This is why we want our instance variables to be private, because we don't want to give users the ability to change instance variables that we have defined for a person. We'll talk more about why that's the case. So you see now it's not letting me do that. It's saying that name, you have to, the fix to this would be changing the visibility from private to public. So I can't do this. And again, I'm going to reiterate that we're going to talk more about why we shouldn't be able to do this. But you get the point as far as creating the basic template. Let's see. I actually wanted that. Let's see here. Window, and then if I go to appearance and I say navigate perspective, and then reset perspective. Okay, so yeah, so you get this so far. Now the question is that, well, if it's the case that the string is the name and age are private, then how exactly am I supposed to change the name and change the age? How do I, well, actually, okay, I'll take a step back and say that we're still on constructors for now, and I've passed in a name and an age, but I can have other choices. Like, let's say I want to give people the ability to basically say P2 equals new person. I just want to be able to have the user just pass in their name. So I want to be able to have the person be able to say David, and they can figure out their age later if they want. How do I do that? And the idea is, well, you overload the constructor. So you basically, now you just want to give a person a name. So you say, well, I can just pass in a name, right? I can just pass in a name, and I can say this dot name is equal to the name that I passed in. And as far as their age is concerned, well, I'm going to say that their age is 0. I'm defaulting it because they haven't decided what their age is going to be. So I'm going to decide for them. I'm going to give them a default age of 0. That way, users can actually now create an object and pass in their name, and they don't have to pass in their age. Of course, I could reverse that order there, or have a new option where you just pass in your age as, let's say, 44. And in that case, I'm going to duplicate this constructor. And in this case, well, I'm just going to have them pass in their age. And so I can default the name to just be an empty quotation. And their age will basically just be what they passed in. They passed in 44. Well, then I'll set that age to 44, the age up here to 44. So why the constructor is important is because it's configuring what the user passed in with the attributes of the object. So does that sort of make sense why a constructor is useful? Yeah. So hopefully that clears up the whole constructor thing. And it is a special type of method. And just remember what the constraints are. And again, you don't really have to remember because I've made notes specifically for this. But just remember that the constructor is a special type of method, as you mentioned, where the name of the method has to match the name of the class. I can't call this, you see, if I mess this around, it'll give me an error. And so these are our overloaded constructors because I overload the combination of parameters that I use. Now, so attributes, constructors, and then methods. Okay. Now the thing is that there are two types of methods in an object. In an object, if there are actions, right? Because remember, we're trying to replicate a real world object. Objects tend to do things. A person can, let's say, speak or walk and so forth. But there are also, back to what I was saying before, how do you set the name and the age if not through here, right? How do you do this? I can't say, I mean, let's say that we were in a situation where I'm using this constructor, or I'm in a situation where I don't pass in anything. I don't pass in anything at all. And of course, I don't have a constructor that just passes nothing, right? In which case I can create that. I can say that the name is just default and the age is 0. This is the default constructor. Now the user has an option just to pass in nothing and just create the object. But the question remains is how can I set the name and the age, because I can't do p1 dot name. I can't do that. It says that it's not allowed. I can't do p1 dot age. There's something called getters and setters. So there are actions and there are getters and setters. Okay. One sec. So, Jesus. So as far as the 1 second. Okay. Right. So the point remains, how do we change the instance variables? So in the methods category, you have actions and you have getters and setters. So I could create a, this is the idea. So they're public, right? And I mentioned that the constructor is also public because you want to be able to access it over here. You want to be able to access that part over here. If I had made that private, this wouldn't have worked out. See that I would have gotten a problem here, right? So it definitely needs to be public. And so as far as the methods are concerned for getters and setters, the setters are going to allow you to set the instance variables to something, to whatever you want. So if they're going to be public, they're not going to return anything because I'm just setting the name or the age. So I can call this set name. By convention, you just take the name of the variable. In this case, it was name. You just preface it by set name. You take the name of the age and say that it's set age. And what's going to happen is they're going to actually pass in the name that they want. And then I'm just going to say, let's say that this is name choice, right? Their name choice that they pass in. So I can say that the name that we have, this name on that level that belongs to the object is actually going to equal the choice, the choice of name that they wanted, right? That's the setter. So I can also call this, I can just call this name, it doesn't matter. I can use the same variable name. And that's the set name, right?
And this method would be used for changing the person's name after they've been instantiated.
Yeah, because the constructor is going to give the default values, right?
Right.
Originally, the constructor is going to give the default values. For this constructor, that's just an empty string, isn't it? And the age is right. So you're right. After the initial instantiation that the constructor does, you have the ability to change your name through this method called set name. And what basically you do is you say, okay, well, they get to pass in a name, and the name that the object has, this is the attribute that the object has, will be set, this dot name will be set to the name they pass in, right?
Okay.
And we'll see that in action. So I'm going to pass in John 22, and essentially that's using which of these constructors do you think?
You say that one more time?
Yeah, what I was saying was I pass in John 22 for the initial variable or in the constructor, and that's using this constructor, isn't it?
Yeah, sorry, my internet's a little bit funky right now.
Oh, that's okay. That's all right. Can you hear me all right? Can you hear me?
Yes.
Okay. Okay. So I can now say p1 dot set name, and I can actually just provide a name that I want now. I can call this David, right? And now what you see is that if I do p1 dot name, p1 dot get name. So this is just going to return the attribute's name, and it has to actually be the return type is going to be of type string, and it's going to return the name of the attribute. Does the getter make sense?
Yes.
Okay, and the setter obviously does. They provide a name, and then I tie the object's attribute to the name they passed in. And so I basically said p1 dot set name David, and then I printed out what that new name is.
So if we instantiated p1 without the name or the age,
Right.
And then we did P1 dot set name David.
Yep.
That would give us, or that would give the name to P1, right?
It would. It would. So what's the or let me just do get name here. What is the output here?
For the first one, it's just an empty string, right?
Yeah, it is.
And the second one, it should be David, right?
It should be. So you see that it's an empty string, so it's just showing nothing. And then on the next line, it's David.
Yes.
I could have said that, it's default name, right? Or, for the empty constructor one.
Mhm.
And you'll see that, oh, this person doesn't have a name yet. When I use the setter, I was able to give a person a name, right?
Yes.
And that's really the idea. So that's why I was saying originally was that the constructor acts as a means to give default values to an object. Sometimes those values are the things that they pass in, and you get to control what they pass in. But it doesn't really still make too much sense why we're using private variables. Because again, it's fine, just give them the ability to set their own name. Why go through the setter and getter? And we'll see that now. So I'm going to basically duplicate, I'm going to create a set age. And again, that return type is void because I don't return anything here. They pass in an age. I take the object, the object attribute age, and I set it to what they pass in. That's the age. And for the get name, I actually want to return an integer here because I actually have to get the name for the program. So I'm going to say get age. And then I'm not going to pass in anything because there's no need to. I know what I want to get. And they don't have to pass in anything because they're not changing anything. I just return the age that belongs to the person. So you see I have set name, get name, set age, get age. Now the thing is that, so let's continue from, I'm going to remove this. We created an object, we passed in a name, it was David, and then we printed it out. Now, the thing is that, let's say now I said p1.setAge, right? And let's say I passed in 4. I'm going to come back here. So at this point, the person has an age and a name, right? I'm going to create a method down here, method for introducing yourself. So this is an action method. A person is equipped with the ability to introduce themselves now. So I'm going to say it's void right now. In fact, I'll keep it as void. I'm not going to return anything. I'm just going to print something out. And I'm going to say introduction. Public void introduction. And I'm going to basically just say system.out.println. Hello, my name is space concatenation, this dot name, another concatenation, and I am concatenation, space before the next, and I am this dot age, years old, right? So this is an introduction. This is going to help us see how we're able to make sense of what I'm about to talk about. So I set the name, I set the age, right? And I'm actually just going to say p1.introduction. I don't have to print out p1.introduction, do I? p1.introduction will come back here and it will do a print statement for me, right?
Cool.
And you say, hello, my name is David, I'm 4 years old, right? Now, the thing is that I could pass in like -5 here, and suddenly in my world of people object, that makes sense because I'm able to print it out. So we want to somehow be able to bind people and basically say that you shouldn't have an age that's negative, right? And this is where I can come over here in the setter. This is why the setter is important. This is why, is I can come in the setter and I can say, if the age they pass in is less than 0, then I basically want to say system.out.println cannot have negative age, else I'll let them do, for all other cases, I'll let them set their age. So you see why it might be important to have a setter, because you want to be able to vet their responses. Let's see here. So when you have a bug like this, you'll actually see an error at the bottom. And when you click on this link, it'll take you to where the error occurred. So in my case, it occurred in person.java on line 41. And you can see here that it took me exactly to where that error happened. And clearly I can see I forgot a semicolon. Okay, there's another error. This is in my program.java, the other file on line 10. And okay, maybe there isn't an error. Let's see. Yeah. So cannot have a negative age. I tried setting it to a negative, and then it said I can't have a negative age. And then guess what happened? It didn't ever set the age, so it just defaulted to the.
It defaulted to 0 because that's what's in our initial constructor, right?
Yeah, for that constructor we chose, it was just 0 for the age. And dude, like when you do this, like if you really want to really learn effectively, try debugging every now and then. So VS Code is going to have a more intuitive way of debugging. This is called a breakpoint. So where you actually want to start debugging, you just put a breakpoint here. In VS Code, it's going to show as red. And this is where my debugging begins. And so I put a breakpoint here, and then I click the bug icon, and then it actually takes me to a different type of screen. That this is my debug mode. And then I can actually, so these are some of the options given to me. I can step into. So what just happened? I started off at the person, and then I stepped into the constructor, right? That was related to. I started here, and then I clicked step into, and then it took me to the constructor. And now if I do step into again, this is more of what happens in the background for Java. It set this name, it set the name attribute to just an empty string, and it set the age attribute to 0. And then I come out, and then now I'm at my set name. And at this point, it'll take me to the setter. It'll say this dot name is equal to the name they passed in. Then it'll bring me back, and then it will go into the set age. And now first it takes that age. It says, is the age less than 0? And then it prints out cannot do that. This is all inbuilt stuff. What happens in the background for Java. These are the classes that they wrote to actually be able to do some of this stuff. So you can actually skip over this stuff, or read it if you wanted to. There's more on this on the documents part of it. Yeah, so you can follow the line of execution by just debugging, and you can, yeah. So that's the idea, right? So that pretty much covers the basic template for object-oriented programming. And just to cover, you have attributes, you have constructors, and you can have overloaded constructors, and then you have setters and getters, and you have actual functions that allow you to do something. In this case, to introduce myself. Usually you'll see that it might be beneficial to introduce a scanner here. Scanner, my scanner equals new scanner, system.in. And get that scanner imported, and basically you can give them the option to enter the names and so forth. So you can just say, my scanner, or enter your name, and then of course, yeah, I'm not really in the habit of the semicolons because of Python, and in Python you don't need
Yeah.
them. So string name is equal, or string name is equal to my scanner dot next line, and then your other one for your age, and age is equal to my scanner dot next line as well, or next int, right? And then after you have these variables, I can, let's say, come up to P1 and I can just pass them in, like, I can pass in the name and the age, and that is going to trigger which constructor? This one, right?
Can you say that one more time?
Yeah, I said that I'm going to use the scanner to get the age and the name, and then I'm going to pass those variables into this constructor.
Right.
And that will actually trigger this constructor, the one with the name and the age, right?
Right.
So that's the idea. So it becomes more interactive that way, and this will be important moving on to the next topic. If I say 23, I didn't really do anything with that information, did I? I just created the object. So I can do p1.introduction here. Yeah, the debugger was still running in the background, I think. So it all works out. Now, this idea of the setters and getters, and the set age and the get age, this is called encapsulation. And that's really one of the first pillars of object-oriented programming, is the idea that you need to abstract away information. Like, the user should not know about your constraints, but they should exist. You should this is called data hiding. So we'll go into, just before I move on to inheritance, we're going to talk a little bit about just just so that we can have some relevance here. Is the process by which data and the code that acts upon them are integrated as a single unit. By encapsulating a class's variables, other classes cannot access them, and only methods of the class. So that's one view of encapsulation, is them being those integers and names and so forth, attributes being private, that they can't be accessed outside of the class. And the main purpose behind that is you should be able to control you should be able to control the age, should be able to control, you should be able to add constraints into how they set things up. And that's the main idea. I'm gonna go into something called inheritance, and so we have all this information down, and the next topic is inheritance. So this is and I guess we'll take a little bit of a break before we do that, and then we'll move on.
If you want to access the objects within class or change any attributes of these objects, you have to use one of their methods.
Yeah.
Okay.
Yep.
Is there anything else?
So I like your sentence as it is, that if you want to change or access a object's attributes, you have to use one of its methods. And then what's the reasoning as to why? Why would I want to use one of their methods? Why should I want to use one of their methods?
Was that, you're asking me, right?
Yeah.
Okay. Okay, it gives that I don't remember that one.
Okay, that's fine. It gives us the ability to control the specifics of what they can and cannot set. So like here, if there wasn't ever a setter, they could put in a negative age, right? Can't they?
Mm-hmm.
If there wasn't a setter. See, the thing is that if I change these to public, if I change these up here to public, I can actually come out here in my programs. And I'm not going to ask for anything right now. I can say P1 dot age is equal to negative 100. And then like my program thinks that's true when I get the name, or when I do P1 dot name. My program thinks that's true, or not P1 dot name, but P1 dot age rather. My program thinks that's valid. Like you can have an age that's negative 100. I want to,
very
yeah,
nice.
I want to force them to go through like a net where I can catch their, illogical thoughts. Like, oh, you wanted an age that was, less than 0? No, you can't do that. So I'm not going to even let you. I'm not going to. This line here, this dot age equals age, gives me the ability to set the age, whatever they pass in to the object, but I'm not going to give them that ability if these happen. It's less than 0 or it's greater than 100. So now, so when I go back, and this is where it gets important, when I go back and they're private, no longer I get an error, right? Errors exist. Proceed. And what does the error say? It says the field person.age is not visible. The field person.age is not visible. So I can go back to where this happens. I can click the error, and it brings me back to this point. I cannot do this. I cannot say I have to. I have to go through P1 dot set age to negative 100, negative 1000. And I can't just print it out. No, I have to go through my getter method. Right? I have to do this. And when I do this, I'm now able to catch it being negative. I can't. What you choose will be scrutinized by me, by what constraints I wish to have. And that's important. So that's encapsulation and data hiding. We don't give them naked data. Like we don't just let them have the name and they can change the name. We hide this data. This is private. We hide this. And we force them, right? That's the idea. And everything else seems that, right? Okay, perfect. So we'll move on to inheritance, which is another big one. And let me just make sure I'm recording here, which I am. Now, inheritance is this idea of inheriting. It's actually inheriting instance variables and methods, instance variables and methods. And we'll see why that's important. So I'm going to establish like a hierarchy of classes. You'll hear that term a lot, a hierarchy of classes, because here, person is when I'm talking about inheritance now, I'm obviously going to introduce other classes, and the relationship between the person class and those other classes is going to they will be structured in a hierarchy. And the hierarchy is that the person is the super class. It is at the top of the hierarchy. It is the super class. Sometimes you'll also call it sometimes you'll also hear it called the base class. This is the class from which all other classes will be based on, which is why they call it the base class. Now, why might that be important? So the term person is such a broad term. An employee is also a person. And so we can create an employee class, and that can be a more nuanced type of class, because the employee might have an attribute like an employee ID. Not all people have employee IDs. Only employees have employee IDs. So does it make sense why I might want another class
Yes.
Right? Because they'll have different attributes. They'll all have a name and age. All employees have a name and age, but only employees will have things specific to them. For instance, a employee ID, work hours, and so forth, right? So I'm going to go back in my programs package, and this, we talk about hierarchy. This is the hierarchy for program structure. You have your project within your this is true for VS Code too. Within your project, you have your source folder, and then within your source folder, you have your packages, and then within your packages, you have your classes. So I'm going to create a class here. I'm going to call it employee. Now, the employee is going to have attributes, properties, right? Also called fields. That we learned that recently, that they're also called fields sometimes. And you're also going to have a constructor. You're also going to have setters and getters and other methods. So walk me through this. Let's say I wanted the employee to have a employee ID. What would you type out here?
I would type int employee, or I guess we do, yeah, and semicolon.
Okay, perfect. And you would want that to be public or private?
Private.
Private, right?
Right.
Okay. For the constructor?
I would do uppercase E employee.
Okay.
And then I suppose I would create one constructor with the employee ID parameter and one without.
Okay, nice.
Well, I guess we wouldn't have to, right? Or
You could, right? One where you pass in the employee ID and the other you don't, right? Maybe we'll
Right.
default the employee ID to like 0 or whatever. Now, would you want them to be public or private?
I would want these to be these constructors.
Yeah,
I would want them to be public, right?
public. Okay. Right. And I'm getting an error here because of two identical constructors, right? And like you said, I'll have one that this dot employee ID equals the employee ID that was just passed in. What do you prefer, by the way? Do you like having this, what they passed in, as a different name?
I guess, well, and this is just a matter of preference,
It is.
or
It's 100% a matter of preference. Like some people, they don't like to do the this dot stuff, so they'll just say, emp ID, right? And they'll maybe say, okay, well, hey, the employee ID that I just had up here is equal to emp ID, right? What they passed in is emp ID, and what the object knows is employee ID.
right.
Do you prefer that?
For sure.
Okay. Okay. But you don't mind if I revert back to this, right? That's more aligned with what I know, or what I use. Okay. And then for this one here, well, not passing anything, right? Then this employee ID equals, let's say, 000. Okay. Now the thing is that, the employees, they also have a name and they also have an age. And they if they have a name and age, then I'm going to write that here, private string age, private int age, private string name. And then I'll have getters and setters. I'll have a get age, set age. I'll have a set, get name, set name. And then now I'm going to have two more. I'll have a get employee ID, set employee ID. But damn, that's a lot of work. That is a lot of work. And ideally, what I'd like to do is only make a getter and setter for the employee ID, because that's the new one here. And that's what inheritance lets us do, is I can actually have the employee extend the person class. As soon as you use the extends keyword, we're now talking about inheritance. And so what's going to happen now is the employee extends person. So the interesting thing here is that the employee is going to have, it will be able to view this, it will be able to view the constructor. And I'll show you kind of what I mean by that. So I can pass in, I can have the int employee ID, and I can also have a string employee name, let's say if they, and I can also have a int employee age. Now, what I can do here is I can go, remember how I said that that the person class is the super class? So I can say super, and I can pass in the employee name and the employee age. So what happened here? I use super, and this super basically calls the constructor of the base class that passes in employee name, that accepts a name and an age. So we go over here, and this constructor accepts a name and an age. And so it basically says this dot name is name, this dot age is age. So now the employee has a name and age associated with it. Does that make sense?
Yes.
Okay. Now let me go ahead and show you something here. So I have a person up here, and I'll just have some default values here like 22. And I'll p1 dot set name Jacob. Now I'm going to create an employee. So employee E1 equals new employee, right? And I am basically going to pass in a Tony 63. Let's see if that, yeah, I have to pass in an employee ID, an employee name, and then so I have to pass in an employee ID too, right? 7882. Okay. So now I can do E1 dot introduction. Hello, my name is Tony. I'm 63 years old. What happened? What just happened? Well, the employee class extended the person, which means it inherited the set name and the get name, everything that was public, it inherited. So employee knows that set age exists. Employee knows get name exists. Employee knows introduction exists, right? And the way it was able to set attributes like that were only a part of the person class, like, name and age were only a part of the person class. They weren't actually in the employee class at all. The way that it was able to set a name and age for itself is by, I passed it in the constructor, and I passed it over to the person constructor, right? I passed name, the employee name and employee age, I passed it over to the person constructor, and it did the setting. And so you can see here that in the main program, I also have things like E1 dot set age. I can set the age now to 32, and I can also do E1 dot get age, and I can set or I can do that name after setting it originally to Jared, right? So all of this is possible, and then I can do E1 dot introduction, right? All of this is possible with this employee object, even though introduction is not a part of the employee class, right? It inherited all the public stuff. So you can see how much typing I just saved myself. I don't have to have a set name, get name, set age, set all that stuff. I just have to do it for employee ID, right? Public set employee ID to whatever they pass in as an integer, right? Integer this dot employee ID equals employee ID, right? Why is this a problem? Because it has to have a return type, right? And public, this time I'm actually going to return the employee ID, right? Employee ID. And then I'm just going to return the employee ID. So that's all I have to do for this. It now has, I'm going to write a comment here and I'm going to say this is what it knows. It has the following: set age, get age, set name, get name, and introduction. It has the following from the person class. Okay, so I don't have to write all that down here. Save myself a lot of time by doing this. I can come back here in the person.
And wait,
yeah,
just to clarify,
okay.
the last method, employee ID, that's a getter, right? Or am I?
Yeah, sorry.
Okay.
Yeah,
I just want to.
you're 100%.
Okay.
That would not be good practice to just name an employee ID. That would not be good practice at all. So yes. So what you can sort of now tell me about this process and whatever you feel could be explained. You're the role now of the teacher, kind of. So tell me about this new concept and what the changes were and stuff.
The relationship between employees and person, right?
Yeah.
Okay. I know that since employee is I don't know what the word is, subclass of
Yeah.
the superclass
Mhm.
person,
Yeah.
that it inherits all of the attribute or fields, I guess.
Yep.
It also inherits all of the methods we have, such as the setters and getters, as well as the non-setter getter methods.
Yep.
So yeah, it has access to everything that the person class has.
Yep.
Right.
We'll talk about that, but yeah.
And I think it has its own attributes that aren't part of the person class.
Yeah.
And yeah, I don't know what else to say about that.
But that's the whole idea, right? So I only had to write the getter and setter for the employee ID, which was the new, that's the only thing specific to employees. So that's the only thing I have to write for. As far as my constructor is concerned, I can pass in, like if the user passes in a name and an age, I can just throw those over to the person constructor that accepts a name and an age, right?
Okay.
Yeah.
So I was just about to ask about super. That's just and yeah, correct me if I'm wrong. So super, and then using those two specific parameters, it calls the constructor in the person class that has those parameters.
Exactly. It will call the constructor of the parent class. And that's exactly how I would have said it. It will specifically call the constructor that has those parameters. So when you get to this point in the program, it will essentially go back to person and it will look for that constructor that passes in a name and an age. Yeah. Okay. Of all my overloaded constructors. So you'll see that if I were to change this, like if I were to do int employee ID here and string employee name here, like this is a employee age, what? No, 1 second, maybe, yeah, employee age. And if I were to switch these around, I actually didn't need to switch them around. The order doesn't matter here, my bad. In fact, yeah, I breed an error if I do that. Let me change that here. So if I were to switch these around, employee age, employee ID, or employee name, right? So why can't I switch them around? I mean, they were okay this way, employee name, employee age, they were okay this way, but why not the other way? If I do employee age and employee name, why can't I do that?
Oh, that ties into, it's called a signature, right?
Yeah,
And
exactly. Yeah,
we have to use that constructor's precise, or we have to just use an existing signature at least, right?
exactly. This is the signature, if we call it, it's different. Like what this is a int and a string. Now the program is going to go back to the person class and look for a constructor that first has an int, then has a string, right? And it doesn't find one. It doesn't find one. So it gives an error, right? So when you do super and you pass in variables like this, the program is now looking back to the parent class and it's frantically searching for any constructor that matches that format. Okay.
Very cool.
So that's the idea. Now I could, let's say I want to have an employee that just passes a name and an age, right? And I'll just default this to 000, let's say, right? That works, doesn't it? So now I can come into my program and I can just, I have the ability to pass in an employee ID, a name, and an age. But now because I did what I just did, I can call this E2 and I can just pass in a name and an age. That works. I can overload this again and I can just pass in. So this is, so you tell me now. I'll remove this. I want to create a constructor. I want this to be valid. I'll show you what I want to be valid. You tell me now. I want this to be valid. What do I do to make that happen?
Okay, so we would do public employee, right? And then we would do string employee name, because we're just passing a name in.
Yep.
And then we would do super employee name. And then I guess the employee ID, should we set a default value for the employee ID?
Yeah,
Okay.
exactly.
Cool.
Yeah. So what's going to happen now is this super is essentially going to trigger. It's going to go back to the parent class and it's going to search for the constructor that had just a parameter, just a name as its parameter, right? See, this is what it sees, super, and then it you see what I'm saying?
Right.
It's kind of what it sees.
Yes.
When I say super employee name, goes back to the super class. It treats them all as super. Oh, this one matches super string name, right? Then it finds it, and then it also gives the age as 0. So I don't have to set a default value for the age here, because it does that in that constructor, right? Okay. And that's why that's why this stuff is useful. Inheritance. Polymorphism and abstraction. They are two that we'll cover later when we get into data structures, because they're more apparent with data structures. But these are by far the most important concepts: encapsulation and inheritance, right? You'll also see this idea of toString, or we might not need to cover it. Well, so toString is basically just a string representation of the object. So I can come down here to person, and it's just a type of introduction type. So you do public string, toString, and you basically say, okay, well, string, this is my this is my string, I'll call it to return, I'll give it a default value of this, and I'll say system.out.print, or no, I'll say to return is equal to basically this line here. So usually objects have a toString method, and return to return. Usually objects have a toString method that is basically just a string representation of the attributes. And we'll sort of see that here if we could search up toString Java. Understanding toString. So there's a toString method that we generally create with these objects, and we can return values of the object. It's good for debugging to have a toString. We can sort of see what this person did as far as their object is concerned. They have a student object, and they have a roll number. I don't know if you know what a roll number is. Do you know that roll number?
No.
Okay, in India, so Geeks for Geeks, or just Java Point is led by Indians, and in India they have, each student has a roll number, which is the equivalent of a student ID, and they have a name in the city. This person did not really do a robust job because they didn't add in the access modifiers. They have a constructor here that takes in the roll number, the name, and the city, and they say this dot roll number is the roll number, this dot name is the name, this dot city is the city, and then they declared two objects here and they passed those in, and then they printed S1 out and S2 out. You can't do this. You can't do this. You can't print out an object like S1. So if we come back here in my program and we try to do system.out.println E1, we can't print out E1. Well, one second. What's going on here? That is because I did something. It's the introduction part. Where is that coming from? P1 person set name. Yeah, so it's using the toString. It's using the toString. But over here, if you did it without the toString, I believe you'd get this. Let's see here. If you didn't have that. Something is suspicious though. Yeah, so if you didn't have the toString, it'll show you the memory location of the object.
Yeah.
But if you have the toString, you can write, it'll override it, and it'll give you a string representation of the object. Okay.
I got you.
All right. So that's that. We'll take a break here. And what I wanted to clarify about inheritance is that when I have employee extend person, I don't actually inherit this, because remember that the instance variables are private, and when they're private, you can't access them outside the class within which they're privated. But what happens is in my employee class, when I do super employee name, employee age, I come to the person and I'm now in this constructor. And through this constructor, I'm able to attach the name that I passed and the age that I passed onto these instances.
Oh, I see.
You get what I'm saying? So we don't just
Yes.
come into the class and like grab all the stuff. This is our entry point, and through the constructor name age, like because inside this constructor you're referring to this, and since person has access to this stuff, it ties it down to employee. That was just a
Mm.
correction there. So it'll inherit all the public stuff. It'll inherit all the public stuff, no problem. But it won't inherit the private stuff. It'll attach itself to the private stuff through the constructor and through the super keyword.
I got you. Okay.
This is actually the first assignment as far as object-oriented programming is concerned. And you can actually use everything like we now have sufficient knowledge to do this to do this assignment, and we'll walk through it. So I'm gonna go in my source folder here, and I'm going to create a new class, and I'm gonna call it bag, because that's what they say that the name should be. And it gives me a lot of hints. It says, well, you want the access modifier to be public for the bag, and the instance variable should be this, right? Why don't actually, you know what? I'm going to pause this, and I'm going to, there's an equivalent. So there, you know how we do Figma and we're able to write real time? There's an equivalent to Figma where we can code together in real time. And you can
Oh.
actually go through this program, and I'll be there while watching you go through it.
Oh, wonderful. Awesome.
That'll be more instructive. There's something called Replit. If you log in here, and this is kind of the equivalent of Figma, where two people can actually code together. So I can create a REPL. Let's see, my REPLs. So your REPLs will be stored on your profile. And if you want to create a REPL, you can click create REPL, and you can do Java, and it'll give you a default relieved euphoric physics. That's how I felt after getting my A. Relieved and euphoric. So you can name it. I'll call it DSA and OOP. You create a REPL. This is kind of the equivalent of a project. And it'll give you an ad for some AI things, like what platform doesn't nowadays. And the idea is that you click run, and obviously, since it's hosted on a website, it'll take just a tad bit longer to run, which is actually really long, but it gets there. Hello world. And so this supports pretty much everything your IDE would support. So you can add classes. Usually the way I like to do it is not to do too much down here or up here. This is your main.java. This will be where your program will run. So if I wanted to create a, let's say a person class, or let's say I want to talk about OOP. So I'll create a folder here. It'll be called OOP. And I'm essentially going to, now when I have clicked OOP, I can now add files to it. So up here you have two options, either add a folder or a file. So if I wanted to add a person class, I could do person.java. It'll give me a suggestion, person.java, employee class, employee.java, and you can just keep adding classes and so forth. So I'll invite you to this REPL, and I'll resume the recording when we're both here, and then try and see if you can I'll send you the PDF. Try and see if you can open the PDF side by side.
Okay.
And then you can code it up. So I'll pause it here for Zoom. We're all set with the REPL here. And you can see the homework, we can see the homework, and go ahead. Feel free to ask clarifying questions, or wherever, whenever, however. And yeah.
Cool. So let's start by creating a class named bag. So I would go to files, We'll create new file. Bag.java.
Yeah.
Is that correct?
Yeah, that is. Yep.
What? No. Bag.java. Thank you. Do public class bag. Cool. And then it's asking, do you have a name? So string name, private string name. Private string. Cool. And then we create a private string name. Yeah, private double current weight. Private double weight. Yes. Private double maximum weight. So we've just defined the attributes of the bag class, right?
Exactly. Those are the and usually they'll also call them instance variables. Any word you want works. Fields, instance variables, or attributes.
Cool. So the constructor, we're going to create the bag constructor. It's going to be what? Public bag, right? And no return type, right?
No return type. Exactly.
This is default constructor, so no parameters. Sets the value 0, 5. Okay. So name equals just an empty string, right?
Yeah.
Cool.
Yeah, this is the default one. So what does that tell you about the default one?
We won't be passing any parameters through.
Exactly. Exactly. And I'll say this for now, that you could have used this dot name or this dot current weight, but it does not make a difference. It knows you're referring to that. So not a problem.
Oh,
It's a
oh,
preference. You don't have, yeah, whatever your preference is. I don't know what the solution has it as, if they've done that or not, but I generally tend to do that.
let's keep things consistent, all right?
Yeah, that's the way I like to do it too.
Sets the value, blah, 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 blah. Cool. Method. So set name. So this is going to be public as well.
Right.
And since it's a setter, it's going to be void, right?
Yeah, it's gonna be void, right? Yeah, exactly.
What we're passing through, will it be name? String name?
Yeah, like I said, it would be preferential. This here they want it to be a variable called new name.
New name.
Yeah, new name. So you wouldn't even have to use, yeah, you see what I'm saying?
Yes.
So the this keyword helps you distinguish between like which, if they're both the same, you'd want to use this keyword. Because like you have to distinguish between like which name is what. But if they're different, then you could just say name equals new name. Or you could do exactly what you did there. As long as they're tied together. I would have done exactly what you have right there. So this is entirely preferential. Yeah.
The variable new name. Cool. Get name.
Yeah.
Public string get name.
Yeah.
Cool. Okay, cool. Return will just be this dot new name, or no?
Yeah.
Or would it just be new name?
It's going to be return this dot name, but why wouldn't it be new name? Why not?
So, oh, okay, I see. So this dot name, we're setting this dot. Okay, I put this. So with the set name method, right? Sure, we're passing in new name. So that's almost like temporary, and that new name is temporary in a sense. And we're assigning it to this dot name. That's concrete. That's going to stay with us.
100%, dude, 100%. Like, I'm going to write just a comment here. So you used two words here. You said temporary and you said concrete. So exactly, right? Concrete are the ones you know will be like consistent. Temporary is just, so the idea is that there is a and you know what, I'm just not gonna obstruct your code too much. I'm just gonna write this down below here after the entire program. Temporary and concrete. So there's something called local scope and global scope. So remember what I said before. I said that the variables up here, do you actually see when I underline something?
I can't see when you underline or anything. No.
Okay. You know, private string name and private double current weight and private double maximum weight. These have something called global scope. In the sense that they, like, every method and every constructor recognizes them. Like, remember on in the bag constructor, you said this dot name, or you could have also just said name, and it would have known what you were talking about. So every method you have and every constructor you have, it knows those global fields. That's why it's global. They're recognized everywhere. And the stuff that you pass in as a parameter over here, it's just known inside inside the set name. After the set name, it's just disregarded. It's actually
local.
Yeah, it's a local scope. Follow me to main for just a minute.
Okay.
And I'm just gonna say that I'm gonna have int x is equal to 5. Actually, I can't really see. Oh yeah, int x is equal to 5, I'll say. Now, when I say if, could you move your cursor just down a little? Yeah. Okay, so if I say if x is equal to 5, then I'm going to introduce a new variable called y, and I'll set that to 10. And I'll say that x is equal to y. And then I'm going to do system.out.println the value of x. So what's the value of x?
X is equal to y. Blah, blah, blah. It's going to be, would it be 10?
Yes, it would be 10. So let me go ahead and run that. Let me know if it's running in real time on your end.
Yeah.
So yeah, it's 10, right?
Yes.
Because I started with x equal to 5, and then I said if x is equal to 5, which means I'm definitely inside this if statement, then, well, it introduced a variable called y, which was 10, and then it set x equal to that variable, and then I printed it out. Now, if I try to print out y, is that possible?
No, because y is a local variable.
Exactly, local. See how it says that the symbol variable y, it just doesn't recognize it. So stuff you declare or instantiate outside will be available to the program at large, but stuff that are within brackets, that exist within brackets only, they're not gonna water through. However, I just want to add this additional point here that if I do int x semicolon, and then let's just say this here, int y is equal to 10 here, and I'm going to say if int y is equal to 10, x is equal to 10. So I can change a value locally, then when I come out of it, it'll still be consistent. Do you see that?
Yeah, as long as it's global to begin with, we can
Yeah.
still change it locally and still use it globally.
Exactly. You can see how it's 10 now.
Yeah.
And the thing is that so I can change values. I can change values of variables locally, and that will change them globally. But if I had done this, let's say, this would not let me continue. This would not let me continue because they have to have, or maybe it would. Yeah, it wouldn't. I have to have default values for something. For have to have I have to have a default value for it,
Hmm.
which would be in this case 0. And that's why constructors are also important. They have to have default values. You see how like the equivalent of having a default value here for X is like 0. So we'll come back to your program and we'll move forward.
Okay. All right. So we finished get name. Add items. So this is going to be an action. It won't be either a setter or a getter, right?
Yeah, so I'm gonna write this down here. Oh, I already wrote global scope and local scope, and I'll just write the definition here. Global scope available to all methods. Local scope only exists inside method. And now I'm gonna write something here. You see those methods that are actions? Action methods are actually called non-static methods. Okay. Methods attached to an object. They're called non-static methods. So when you refer to get name, set name, and action methods, those are all non-static methods. They don't have the static keyword in them. So if the method is attached to an object, it's called a non-static method. Okay.
Okay.
So non-static method, methods attached to an object. If attached to an object, the static method. Okay, you can continue. I'm just clearing up terminology.
Wait, hey, can you give me one moment?
Yes, take your time.
I'm sorry.
That's fine.
So sorry about that. All right. Okay, so yeah, we'll be doing an action method,
Yeah, a non-static method, right?
right? Non-static, and it's non-static because it's attached to an object.
Exactly.
Okay, my question is, if will it always be a static method if it's in the main method
Yeah.
or in the main class?
Yeah, like if I have a, so this is here, are you with me here in the main method, in the main class?
Let me get back to it.
Are you here?
Yes.
Okay, so public static add in x and y, return x plus y. So int result is equal to calling the add function now, 3 and 2, 4 and 2, and then system.out.print line result. So this is an example of a static method. So I don't want to call this a method. Don't call this a method. Public int, public static int, sorry. This is a static method. Sorry, don't call it a method, call it a function. It's not attached to an object.
Okay.
These are functions, okay? They execute a task. When the function is attached to an object, we call it a method.
Okay.
So this one is, it's just, these functions are static if their sole purpose is just to communicate to the main class, then you'll call them static. They're not, this is not attached to an object.
Okay. Okay, cool.
Okay, awesome.
Awesome. So are we not calling it a method because it's genuinely not a method, or is function just a better way to describe it?
No. Functions are not attached to objects. So I'll go ahead and do a little bit of Googling here, but the main idea is that the functions are not attached to objects. They are in a way, it's just that we call them methods, just so that we're able to distinguish between, like if I say a function, I'm gonna start thinking of some like add number function like I just made.
Right.
If you say like a method, I'm gonna think of some type of, thing that is part of an object. So I'm gonna write here method versus function in Java. Function is an independent functionality. Method lies under object-oriented programming, right?
Okay.
Like what I had just done on with the main method here with the add, like this had nothing to do with object-oriented programming. I did this without any knowledge of object-oriented programming. So the get name and the set name, that's part of the object-oriented programming category. Those are methods. So function is an independent functionality, has nothing to do with anything else. It just adds two numbers. It's not a part of some class. Well, it is a part of a class. It's just not like, so while the method lies under object-oriented programming, in functions, we don't need to declare the class. While to use methods, we need to declare the class. A lot of good stuff here. Now, there is an argument that that in the main method here, this too is just a part of the object-oriented programming paradigm. Like this is a main, this is a, but this is just different from that. Okay. Does that sound good?
Yeah.
Methods were with objects. So the objects will have non-static methods. None of them are going to have a static keyword in them. Okay.
Okay. Hey, Ram.
Hmm?
So sorry, bro. I have to head out. I have to pick up my sister from work.
Oh, no problem. No problem, dude. Yeah. We'll do a part 2 and merge that part with this one.
Dude, thank you so much. You've illuminated so much